Students, this is Unit 2, Segments, Lines, and Angles, Lesson 2.3, Segment Properties. You're taking a look right here, and you are recording the location, date, and time you're watching this video prior to class. Don't forget a parent or guardian sign-off. All right, I'd like you to take a shot at this page on your own. Pause the video, then restart when you're ready to check. Pause. Welcome back. So you're supposed to multiply and simplify the radicals. So you start by multiplying the outies. It's going to be 2 times 3, and then you multiply the innies. 6 times 8. And simplify. So the way I'm going to simplify is I'm going to break both of these down because they can be broken down. So I have a 2 and a 3, and then here I have a 2 and a 4, and another 2 and a 2. So your goal is to see who has a date here. You don't look at the branch, and the branch right here is going to be 4, so you're not looking at that. So we see here we have one pair of 2s. They're going to come out on the outside. And I have another pair of 2s that come out on the outside. And then we look at who does not have a date, and that's going to be the 3. So up here, that's 2 times 2 times 2. That's 8 times 3. Final answer, that's going to be 24 square root. And then right there, stays home and has pizza. So you should have gotten 24 root 3. And for this one, we're going to graph using intercepts or y equals mx plus b. And I'm going to go ahead, and this is really simple. We just need to get rid of the date for y. So we're going to divide -5. Make sure she gossips to everybody. So we have y equals -1/5 x, double negative makes a positive 3. So right underneath, we write y equals mx plus b, and our b is positive 3. We take a look at our slope. Our slope is going to be negative. So it's going to be rise 1 and run 5. So I'm going to rise 1 and run 5, and I'm going to go to the left to make it negative. 1, 2, 3, 4, and 5. Or I can go this way, down 1, and over 5 this way. 1, 2, 3, 4, and 5. All right. That's a couple reviews. Now let's dig into what we're going to talk about today. We're going to talk about properties of segments. Properties of segments. So by the end of today's lesson, you need to be comfortable with these words. Distance, constructions, segment addition, midpoint, bisector, the word hatch marks, symmetric, reflexive, transitive. So the study of segments, any kind of drawing and construction and architecture, all of these concepts are involved. And there's 3 things we have to be able to do with segments. Now remember, segments, here's a line. A segment is just a piece of a line. So it has distinct endpoints. And there's 3 things you have to be able to deal with that segment. 1, you have to be able to measure them. 2, you have to be able to add them. And 3, we have to be able to deal with what's called the midpoint or the bisector. So we're doing all 3, measuring, adding, midpoint, and bisector. Let's first talk about measurement here. So right here, it says plot these points. connect them and make those segments. So we have a segment DF, which is a piece of a line, and a segment JK, which is a piece of a line. Let's bunny hop and find the length or the measure or the distance between D and F. Distance is 7 units. Let's bunny hop the other one. Distance is also 7 units. Now just take a very close look. Notice 0 is right there. So even though this red segment is completely and totally on the negative side of the number line, its distance, the actual numerical distance or length, if you will, or measure of this segment is always positive. Distance is always positive. Distance is always positive. So when we see the word distance, we're always talking about a positive measurement. So let me talk briefly about some notations in math and geometry. So here we have this segment, D, F, and this segment, JK. Now, if I want to say the distance of DF is 7 units and the distance of JK is 7 units, you use this notation. If I want to say distance, I say DF equals. And then on this side, you put the actual measure. We use an equal sign for concepts of numerical measure. So DF is 7 units. Notice it is absent. There is no segment thing above it. Why? Because without that notation and with the use of an equal sign, I am asking for a number on the other side, a numerical measurement. So right here, the distance of J to K, notice the equal sign, the distance of J to K is also 7 units. When we use an equal sign, it means put a measurement on the other side. Now, watch this notation. This is a new notation to you. If I want to compare things, not measurements, things. I want to compare a thing to a thing, and I say they are of equivalent nature. So just put that sign right there, a thing to a thing. We use that symbol right there. That word, that symbol is congruent. So I would write it like this. If I want to say DF, the segment, and JK, the segment, are congruent, one, I put a hatch mark on both of those. That means of equal length. And I write it like this. DF, the segment, is congruent to JK, the segment. I'm comparing the lengths of the segments. Let's plot these points. We have A is at -9. And B is at -4. And C is at 0. D is at 3. E is at 5. And F is at 9. Now I want you to find those distances down below. Pause. Welcome back. Let's check here. The distance from A to E, that's basically 9 plus 5, is 14 units. B to C, notice I'm physically bracketing, is going to be 4 units, not negative, because distance is always positive. B to F, that's -4 to +9. That's basically 4 plus 9. And D to A, it's going to be 3 to -9. That's 12 units. Okay, so all of that is dealing with how to measure a segment. Measure. Take a moment and repeat to yourself, what did you learn about this page? By far the most important thing you need to know the difference of is the difference between the use of an equal sign and the use of this congruent sign. Pause. Welcome back. Now we're going to learn to add segments. This is not complicated, pretty simple. Let's pause and let's add these segments right here. We have S is at -8. Now let's find the distances between these. I want the distance between S and T. So physically bracket, get in the habit of bracketing distances. You can see that's -8 to 0, so that's going to be 8 units. Let's bracket T to U. Five units. Let's bracket S to U. That's going to be 13 units. So this is a real simple concept. Little segments add up to bigger segments. So for example, the distance of S to T plus the distance of T to U. Notice I'm not using segments because that technically means the distance. I'm color coding it for you. Equals the distance S to U. Little segments add up to bigger segments. This isn't meant to be complicated, guys. 8 plus 5, for those who need to see this numerically, is, woohoo, 13. See? It all fits together. Let's actually do a problem here. It says, draw a segment with 3 collinear points, J, K, and L, where point K is between J and L. The distance JK is 2x. The distance KL is 5x minus 10. The distance j to L is 8x minus 18. Find everything possible. I want you to take a moment and to the best of your ability, I want you to try to draw and label this yourself. Draw and label it yourself. Don't do anything with it. Just draw and label it yourself, and then restart the video. Pause. Okay, let's see what you have here. First off, we have a segment. On this segment, we have 3 points, J, K, and L, where K is between. Notice I didn't put K right in the middle. Don't put it in the middle unless you are told it's in the middle. Okay, ready? The distance of J to K, so I'm going to bracket that, is 2x. The distance of K to L is 5x minus 10. And then we're told the distance J to L, oops, that's L there. The distance J to L is 8x minus 18. Now notice, very annoyingly so, I don't even tell you what to find. I just say find what you can find, everything possible. So you ask yourself logically, what's going on here? And you always want to think in terms of thing first. Think in terms of things before you think in terms of numbers. You guys are used to doing numbers in algebra, but geometry is not about the numbers, it's about the diagram. Let me show you what I mean about things. We know, this works really well if you color code it. We know this blue segment JK. Let me put it over here. So we're going to do some algebra here. This blue segment JK plus the purple segment K to L equals the red segment, the distance of the red segment J to L. That's called a things first equation. You think in terms of things, not numbers. Especially helpful if you color code. Ready? Circle, plug, chug. Circle JK. Circle this. Plug it in. All right, so it says find what you can find. I think it's pretty easy. Let's go ahead and solve for x. Now, if this were algebra, you'd be done. You're like, yay, I solved for the variable. I am done. But this is geometry. You are not. You always ask yourself, is there anything else I can find after the variable? Well, let's see what we just found. We just found that x is 8. Looky there. That means I can plug that in. Let's go ahead and plug that in and see what we get. Ready? So we're going to do this. We know J to K, the distance J to K, that's blue. That's going to be 2 times 8 We just found the distance of this segment is 16. And now we're going to do K to L. And we know that this is going to equal 30. And now let's do J to L. And when you figure that out, that's going to be 46. And look, it actually fits together. It's so easy to check these problems because if you look carefully, everything fits. 16 plus 30 equals 46. Now we have found everything possible. That's called adding segments. So what have we done? We've talked about the measure of segments and segments being congruent. We've talked about how little segments add up to bigger segments. And on that note, I want you to go ahead and try this page on your own. Pause. Welcome back. Let's see how you did. First off, we have a segment, 3 collinear points of C, A, and T. C, A, T, where A is between C and T. The distance of TA is 10 more than 3 times the distance A to C. So we're comparing A to C. So A to C is going to be X. A to C we're just going to call as unknown. And right here, TA is 10 more than 3 times of CA. So that's going to be 10 more than 3 times of CA. And the distance C to T is 30 units. Find everything possible. Remember, we do a things first equation, things first. And the things first equation says this, the distance of CA plus the distance of A to T equals the distance C to T. Now we can circle plug check. CA is our unknown. AT is 10 plus 3 times the unknown. Let's keep my colors the same here. Equals 30. Let's solve. Collect like terms. Woohoo! X equals 5. You think you're done, but remember, this is a find everything possible. So you have to take that variable and put it back in here. And so we just figured out X is 5, so that means this is 5. This is going to be 3 times 5 plus 10, so that means this is 25. And then they should add up to 30. You've done this correctly. 5 plus 25 equals 30. Absolutely. All righty, here's the next page. Didn't show up on that, so I had to bring it up here. Next page, we're going to talk about a midpoint versus a bisector. A midpoint versus the bisector. It says right here, draw a segment HI with the midpoint of M. Also, point N is the midpoint MI. Let's start one thing at a time. It says, draw a segment HI with the midpoint of M. So we're just going to do that. So we have a segment. That segment is HI, and we have an exact middle of M. Now watch very carefully. You must have hatch marks to say that M is in the exact middle. That one set of hatch marks means that those two pieces are equal. If you don't have hatch marks, you don't have a midpoint. No hatch marks, no midpoint. Now it says point N is the exact middle of M to I. So here's M to I, a little bracket. So we're going to add point N here because N is the midpoint of M to I, and it's our second set. We have a second set of hatch marks. So the red hatch marks means M is the middle of HI, and the blue hatch marks, the double ones, are second set, ends the middle there. Versus this, it says draw segment HI which is bisected by a line YZ at point M. That still makes M the midpoint. That means HI is being cut in half by that line. So this right here would be considered a bisector. Anything other than a point that goes through the middle is called a bisector, and we would call exactly point M a midpoint. Once again, if you don't have hatch marks, you do not have a bisector in math notation. No hatch marks, no bisector. Okay, so what I want you to do is just to read these out loud, attempt to draw them, and then restart the video and we'll check. Pause. Welcome back. Let's check out, see how well you did. Again, reading out loud really helps here. It says draw a segment ST with the midpoint of U. So we're going to start with that. We have a segment ST with the midpoint of U. So U's exactly in the middle, must have those hatch marks. Then draw a ray UW. Notice there's U again. That means U's the endpoint. We're drawing a ray going towards W, with point Z is at the midpoint of the segment UW. So the segment's going to be this orange piece. It starts and stops right there. And Z is the exact middle there. Because it's our second midpoint in the same diagram, you had to have two hatch marks. Now, if you did double hatch marks right here, give yourself a giant star, because that was tricky. Let's try this last one. It says draw a line EG. So it first says that E and G are a line. Now, point F is a midpoint of the segment EG. So segment EG would be this piece right here. And F is the exact middle. That's my sound effects for hatch marks. It says line M bisects EG at point F. So line M goes through EG at point F. Next, B and C are collinear on line M, so that point F is also the midpoint of BC. So B and C are collinear. That means they're on the line M, and F is the exact middle going that way. So right now, if we want to cut this segment in half, B to C, we have hatch mark. Double hatch, because it's your second set. Once again, if you actually put double hatch marks there, give yourself a giant star, smiley, some other I'm such a brilliant young person notation. Good job.